Okay, folks, we're back again. Today is going to be lesson 15, the diagonal rule. Before we go into the diagonal rule, let's review real quick what we did yesterday. Yesterday we talked about the four principal quantum numbers, and we said that they were the definition for principal quantum number was that it's simply the location of the electrons. We said that there were four quantum numbers. The first one was the principal quantum number. And the principal quantum number is nothing more than just the energy levels. And we said that there were 7 of them. 1, 2, 3, 4, 5, 6, and 7. We also said that the second quantum number is where the electrons go on those energy levels. They go to a sublevel, and the sublevels are named S, P, D, and F. After they go on the sublevel, they go into certain orbitals, which is the third quantum number. And different orbitals, different sublevels have different number of orbitals. The S has 1, the P has 3, the D has 5, and the F has 7. And then on those orbitals, the electrons, as they fill them, they start to spin. And this is what's called the fourth quantum number, and they spin in a certain direction. In this case, the orbital on the S sublevel, one electron is spinning one way, and the next electron is spinning the other way. And we place arrows up and down so that we can tell which spin they go on. Alright, today, the diagonal rule. The diagonal rule, by definition, let me get my paper out here. The diagonal rule is simply the order in which the electrons fill the energy levels. The order in which the electrons fill the energy levels. We know that the principal quantum number is 1 through 7. And we know that the sublevels are S, P, D, or F. And we know there are a certain number of orbitals on each sublevel. And we know they spin in a certain direction. What we don't know is the order in which they fill them. And so basically, the diagonal rule simply shows us what order they fill it. Okay, before I show you the diagonal rule, or before we draw it, there is something we need to know. We need to know the maximum number of electrons on any energy level. So write down the maximum number of electrons on any energy level. Now, because I use the word any, it's not going to be just a number. It's going to sort of kind of be like a formula. The maximum number of electrons, if I ask you that, a lot of you would raise your hand and you would say 8. And as you listen to the previous videos, some of you may say, well, 2, or 8, or 18. And well, I'm going to show you an easy way of figuring out what it is. If I ask you this question, the maximum number of electrons on any energy level, the answer is 2n squared. And n squared is in parentheses. Now, do you remember what n stood for? N stands for the energy level, or the principal quantum number. And these can be 1, 2, 3, 4, 5, 6, or 7. All right, so let's take a look at this real quick. If our energy level was 1, our first energy level, if we put 1 in for n, 1 squared, 1 times 1 is 1, times 2 is 2. So the maximum number of electrons would be 2. If we go to our second energy level, and we put a 2 in for n squared is 4, times 2 is 8. So the maximum number of electrons on the second energy level would be 8. If we go to our third energy level, I'll put a little e here for electrons. These are the energy levels. If we go to our third energy level, the maximum number of electrons, put 3 in for n squared, 3 times 3 is 9, times 2 is 18. So the maximum number of electrons on the third energy level is 18. If we go to our fourth energy level, and we put 4 in for n squared is, 4 times 4 is 16. 16 times 2 is 32. Okay, let's go to our fifth energy level. If we put a 5 in for n squared is 25. 25 times 2 is 50. So the maximum number of electrons on the fifth energy level is going to be 50. Now I'm running out of room here. Yeah, I'll just do this. Six. Let me move it up a little bit. Okay, if we go to our sixth energy level, if we put 6 in for n, 6 times 6 is 36, times 2 would be 72. So I can have 72 electrons on the sixth energy level. And then my seventh energy level, which is the largest one, 7 times 7 is 49. 49 times 2 is 98. So I can have a 98 electron on the seventh energy level. Now we don't go that high, to be honest with you. We use probably the 1, 2, 3, 4th energy levels, and that's it in what we do. But just to let you know, if I ever ask you what is the maximum number of electrons on any energy level, it's 2n squared. Now if the question was, what is the maximum number of electrons on the third energy level, you would put a 3 in here and say 3 times 3 is 9, times 2 is 18, and like right here says third energy level, 18 electrons. That's the maximum number. Now I want you to understand, let's say we go to the second energy level. It doesn't have to have 8. It could have 1, 2, 3, 4, 5, 6, 7, 8 electrons there. It depends on what element is there. Same way with the first energy level. You know, it doesn't have to have 2. It could have 1 there. It could have 1 or 2. So understand these are the maximum number of electrons on any energy level. Okay? All right, we had to get that out of the way real quick before we talked about the diagonal rule. Okay, so let's start talking about the diagonal rule. What I would do if I was you, I would get a start on the top of the next page on your notes, because we're going to have to draw it out. I'll tell you what, real quick before we go on to that. Now, we'll do it. All right. Don't write down exactly what I have until I tell you what to write, and just watch. I went ahead and got a regular paper to show you. So we're going to skip a line between every one I do here. I'm going to put down what's called the diagonal rule. I'm going to write it down. That's my first energy level. This is my second energy level. This is my third energy level. This is my fourth energy level. This is my fifth energy level. My sixth energy level. Let me go up a little. And my seventh energy level. Now I'm going to give me plenty of room. Now the first column here are the S's. So my first energy level, my sub-level is S. My second energy level, my sub-level is S. My third energy level, my sub-level is S. Fourth, S, 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 and S. Okay, just watch what I do before you write a little bit. Now over here, I'm going to do the same thing. But I'm going to not put the first energy level. I'm going to put 2, 3, 4, 5, 6, and 7. Now this time, my sub-levels are not going to be my S's. In this case, my sub-levels are going to be my P's. Okay, let's do my third column. These are still going to be my second energy level. Hold on. No, right here. Third energy level, fourth, fifth, sixth, seventh. So I got my S sublevel, P sublevel. Now I have my D sublevel. See the 7s down there? All right. And then my last column, I've got my 4, 5, 6, and 7. And I have my S, P, D, and now I have my F sublevel. Now, before, we were talking about how many electrons can go on the sublevels. Well, on my S's, there are 2 electrons on the maximum number on my S's. So I can put a little 2 electrons on every one of these S's and a superscript up there. My P's, the maximum number of electrons on my P's are 6. So I'm going to put a little 6 on my superscript right after and above my P's. On my D's, the maximum numbers, my sublevel D's, the maximum number of electrons are going to be 10. And on my F's, the maximum number of electrons on that would be 14. Now this is the basic map in order for us to fill our energy levels. But I have to have a route to go on this map. And I'm hoping maybe orange will work. Okay, this is the route. You don't draw it till after I draw it because you might make a mistake. Because it's called the diagonal rule, I'm going to go diagonally with our route, or how we're going to go. So I'll put my pencil right here and put an arrow just like that. And then once I go through that path, I'm going to come over here and go through this path. And then I'm going to come right over here and come down through here. Just watch what I'm doing real quick. Then go from here down, here down. Notice the diagonal paths that I'm drawing. When you end up doing this, make sure you hit the correct levels and sublevels. All right. This is what we call the diagonal rule, and this is how we follow it. Well, I'll give you time just to draw those arrows just like that real quick. Okay, as you're drawing those arrows, this is how we're going to follow this. A lot of times students make a mistake and they just do all the ones first and the twos and the threes and the fours and the fives. Well, that's a mistake. We've put these arrows to show us how the electrons fill the energy levels. So this is where we start. We come up here to the top and we go down this arrow. Now the first arrow we go down through, the first energy level we hit is number 1, and we go to the S sublevel. So electrons start filling the 1s first. Okay? There can be a maximum of 2 electrons on that sublevel. Okay? Now once we get 2 on there, we come up to this next line and we go down and follow it, and the next one we come to is our 2s. So it fills the 2s. And then we keep following it. We come to the end of the arrow, so we go up to the top of the next arrow. The next level and sublevel we're going to fill is the 2p. Now we can have a maximum of 6 electrons on there, and then once we get that filled up, we go to the 3s. Okay, once we fill that one up, we come up here to the next arrow, and we follow it down and we go to the 3p. And we can fill 6 electrons on the 3p. And then once we fill that up, we come back down here and all of a sudden we go to the 4s. And we fill 2 there. Now so far it's been pretty easy. We've gone 1, 2, 3, and 4. Now the next number, it seems to go down. But notice, we're at the end of this arrow, so we come back up here to the top of the next arrow. And as we start coming down, we go to the 3d. Now we went back in energy level, but that's the path that is follows. And we can put 10 electrons on the 3d. Once we get 10 electrons on the 3d, we come down here and go to the 4p. And then once we fill that up with 6, we come to the 5s. We go to the end of the arrow, come back up here, and follow it. And it's the 4d, which starts filling electrons next. And then the 5p, and then the 6s. And it just keeps on going. Come up here to the next arrow, and it goes 4f, 5d, 6p, 7s. And over here it just follows on down, come to the end of the arrow, falls over here. Now we very seldom get to these right over here. Most of ours are right in here, but that is how we follow the diagonal rule. And the diagonal rule is simply a map or a guide into allowing us to put electrons where they're supposed to go around the nucleus of an atom. So real quick, let me show you again. I'm just going to go and you can follow along with me or say it to yourself or out loud, the energy levels in which they start filling. First we fill the 1s, then the 2s, then the 2p, 3s, then the 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, 4f, 5d, 6p, 7s, 5f, 6d, 7p, 6f, 7d. That is the path or the order in which we fill electrons around the nucleus. Okay, we're going to look at some examples real quick.